All right, so as a continuation of our previous class under the applications of Newton law, now there are several applications, okay, and one of them is block and cord system, which is also known as air track glider. Okay, now block and cord system is kind of similar to motions of connected particle, but they are different. Okay, the applications are known, they are different, but they have some similarities. Okay, now unlike motions of connected particle, when two bodies are connected by what, by a string over a frictionless pulley, in an electric ladder, one of the mass or one of the body usually at the surface, okay, while the other one is usually suspended. I don't know if you understand. But in motions of connected particles or connected bodies, both masses or both bodies, they are what? They are suspended. But in electric ladder, one of the bodies is suspended while the other one is not suspended. Okay. Now, important things you need to take note of under air traffic glider or block and cord system is that the tension acting on M1 and the tension acting on M2 are the same. Okay, so tension equals tension. The tension acting on them are the same or are equal. Okay, yes. Now, unlike motions of connected bodies, whereby the direction of motion is determined by the heavier mass, is determined by the heavier mass. But in an electric ladder, the direction of the motion is determined by what? The M2. Okay, yes, because the M2 is usually suspended. Okay, so it's usually the M2. The direction of motion is always like this. Is always like this. Okay, always like this. Okay, this M2 is drawing the M1. I don't even understand. The M2 is suspended and as it's going down, it's taking the M1 with him. Okay, yes. So the tension acting on M1 and M2 is the same. The direction of the motion is determined by what? M2. And that is to tell you that M2 is always greater than what? M1. Okay, because if M2 is not greater than M1, there will be no motion. Okay, so M2 is always greater than M1. Okay, then try that thing again. Direction of motion is always like this. Yes, direction of motion is always like this. Okay, tensions are the same. Then yes, now let's start now. In questions they will ask you to calculate for it. Either questions coming out from electric glider or block and cord system, they will either ask you to calculate for what? For the common acceleration of what? Of these two masses. Yes. Look at the question on the board. The acceleration of the glider, yes, they will ask you to calculate for what? Their common acceleration. They also ask you to calculate for the tension. Tension are the same. They also can ask you to calculate for the force acting on the whole system. Okay, so that is where you expect questions from. They'll ask you to calculate for their common acceleration, their tension, and what's the total force acting on what? Acting on the entire system. Okay, so just like the way we did motions of connected particles, the same applies in electric glider. Okay, now let's start now. It's very easy. Let's derive the equation for their common acceleration, for their tension, as well as the force acting on the system. Okay, so let's derive their common acceleration first. Okay, now let's start with this part. Now, okay, let's start with this part. Okay, so how many, this is M1. How many forces are acting on M1? Normally, if you look at it, we have N, which is not normal reactional force. We have the weight of M1. Then we also have tension. So these are three forces, right? Yes. But if you look at it, the normal reactional force and the weight balance each other. They cancel out. I don't even understand. So that's to tell you that it is only tension. It's only tension that is acting on what? On M1. I don't know if you understand. Because because if you look at, I told you guys in the recent classes that when a body is on a surface, when a mass is on a surface, when a block is on a surface, there's usually this upward resistance force exerted by the surface, and that upward resistance force is known as what? Is known as the normal reactional force. Then this body, the body itself exerts what? A downward force known as the weight. So these two usually balance each other. Okay, these two usually balance each other. The normal reactional force equals to the weight. Okay, so this is what happens here. They balance each other, they cancel out. Okay, so the force acting on M1 is just tension. Okay, so just like we did this one, then the total force acting on what? On M1 is just only the tension, right? So total force acting on M1 is just equals to what? Only is equals to what? The tension. Okay. Now what about M2? M2, there are two forces, the weight and what? The tension. Okay. So total force acting on what? On M2 will be what? Will be the tension. Tension is going upward, then weight is going down. Okay. So yes. So let's continue. Now total force is equals to what? MA, right? So MA, since we are using M1, it will now be what? M1A equals to what? Tension. Okay, so this is the tension in this place. Okay, now the acceleration, look at it, the acceleration is going towards this side, and this side, according to the coordinates, remember that upward is positive, downward is negative, to the west is negative, while to the east is what? Is positive. Okay, so the acceleration is what? Is positive, because the acceleration is going towards the what? Towards the east, so it's positive. Okay, now let's go to this side. The total force is equal to what? M2A, right? M2 in total force acting on M2 is what? Is M2A, right? Equals to tension minus 1 W2. Now the acceleration, let's look at it. M2 is going downwards, right? It's accelerating downwards. Okay, and remember, going down is what? Is negative, right? So therefore the acceleration, I'm coming, therefore the acceleration is what? The acceleration, this acceleration is value or negative, because what? Is going down, right? So now be what? M2 times what? Minus A, right? M2 times minus A, right? If you multiply everything, you get some, you have what? Minus M2A, right? Yes. Now since you are looking for it, since you want to make tension stand alone, this one minus W2 will be crossed over this side, and as it's crossing, it will turn what? It will turn positive, right? So it now be what? W2 to turn positive, right? Then this minus M2A equals to what? Tension, right? Yes. Now W2, where is weight? Weight is normally what? Weight is normally mg, right? Since the weight is acting on M2, it will not be what? M2g, right? So this one will not be what? Will not be M2g. Okay, so this is the tension acting on what? This is the tension acting on what? M2. Why this is the tension acting on M1? Okay, now as I said earlier, tension acting on M1 and tension acting on M2, they are the same. Okay, so they are equal. All right, so if in particular, in this particular, let's say if you look at this question and say calculate the tension in the string, we can use this one straightforward. We can use this one straightforward as well. Okay, so we are not done yet. We are to derive we are looking for the equation to calculate for the common acceleration, right? So we arrive here. Now let's continue to this part. Okay, now since the tension acting on M1 is the same as the tension acting on M2, M1 tension is what? Is M1 here, right? So M1A. What about tension acting on M2? Tension acting on M2 is equal to what? M2G minus what? M2A, right? Yes. Now since we are looking for the common acceleration, the masses that have, we take the masses that have acceleration to one side and the masses that have g to the other side. Okay, so we take this one to this side. Okay, so this mass that has acceleration, take it to this other side. Okay, that also has acceleration. So if M2A crosses to this side, if minus M2A crosses to this side, it will not be what? It should not turn positive, right? So it will not be what? M1A plus what? M2A equals to what? M2G, right? Okay, so which A is common between these two masses, right? So bring out A, then bracket open, M1 plus what? M2, bracket close, equals to M2G. So since we are looking for A, we divide both sides by what? Divide both sides by M1 plus M2. Okay, divide both sides by M1 plus M2. So we cancel that A will not be what? A will not be equals to what? M2G over what? M1 plus M2. Okay, so this is the equation to calculate for what? Their common acceleration. Okay, so If we want to calculate for the common acceleration now, we use all this equation, okay? Yes. Now worry about the tension, we can use any of this one because why the tensions are what? Are equal. Now the last part, and this is the formula to calculate for the common acceleration. This one is for the tension. Now worry about their I calculate this part now, okay? Worry about their total force. Okay, to calculate the formula to calculate for total force is very easy. Their total force or their net force is equals to the square root of what? Of t of their tension. Okay, the square of each of the tension. Okay, now let's continue. Now t square plus t square we equal what? Now remember, according to mass, when the same thing is when you add the same thing to give you 2 of that thing, a plus a give us what? 2a. I don't know if you understand. A square plus a square will give us what? 2a square. I don't know if you understand. B square plus b square will give us what? 2b square, right? So let's add this one. T square plus t square will give us what? Will give us 2t square, right? Yes. Now this square will cancel this square root. I don't understand. Now remember, let me break it down for you. This one cancel this square root, remember this 2 is also affected by this square root. I don't know if you understand. I don't know if you get. Now this square will cancel this. Let me just break it down for you. Now this one here, you see the same thing as what? Root 2 times what? Root t square. I'm coming. Root 2 times root t square. I don't know if you understand. This 2 is the same thing as this. Okay? So if this one cancel this one now, we'll be left with what? T. Remember, we still have what? Root 2, right? Root 2 times t will give us what? Root 2t. I don't know if you understand. Root 2t. I don't know if you get. So let's do it again. Okay? So let's do it again. So t square plus t square will give us what? Give us 2t square, right? Yes. Now this square root affects both the 2 and the t square. Now this square will cancel the square root. We'll be left with what? We'll be left with only root 2. Then and what? Just t, right? Just t. Okay. So that is just it. So this is the formula to calculate for what? The total force. Okay. Now if we go further, root 2 is equal to what? 1.4142. That is root 2. If you look at the square root of 2 is 1.4142. Then plus the t. Okay, so this is the formula we can use to calculate for what? Their net force. Okay, yes, this is the formula. Okay, you can use this one or you can use this or this at the same thing. Okay, so yes, this to calculate for the common acceleration. This one is to calculate for what? Their tension. Okay, you can use any of them. While this one is to calculate for what? For what? Their total force, right? So let's look at the acceleration first. Okay, so using this formula, now let's read the question. If an neutral glider of 2 kg mass is connected to a mass of what? Of 0.0115 kg with a spring over a frictionless pulley, what is the acceleration of the glider? Okay, so let's look for the acceleration of the glider. Okay, so we look for the acceleration of the glider. Now using this formula, a equals to what? A equals to m2g minus what? m1 plus what? m2. Okay, so our m2 is what? Remember, the very first mass is what? The very first mass is what? Is m1. Okay, and the m1 is what? Is 2 kg. Okay, then our m2 will be what? Our m2 will be 0. What? Our m2 will be what? 0.015 kg. Okay, so now let's continue. Okay, so that be 2 times what? 2 times, I'm coming. That be what? 0.015 times g is 10. Okay, all over what? m1 is 2, then plus m2 is what? 0.015. Okay, so if we multiply everything and divide them, let's see. So 0.015 times 10, then divide by what? 2 plus 0.015. Okay, so if we do it, we do everything, our acceleration will be 0.0744 meter per second. Okay, square. This is our acceleration. Okay, now they're asking us, the next question is they're asking us for the tension. Okay, so what is the tension? Now I told you guys that the tension here, this tension is still the same thing as this tension. Okay, the tension acting on M1 is equal to the tension acting on what? On M2. Okay, so we can use this one. If we use this one, we get our answer. If we use this one, we also get our answer. Okay, so let's use this one. Our M1 will be what? Our M1 is 2, right? So 2 times what? 2 times the acceleration is what? 0.0744. Okay, so let's multiply it. Okay, so let's multiply. I'm coming. Okay, so times. Okay, so when we multiply everything, our tension is equal to what? 0.148 Newton. Okay, so let's use this one. Let's use this other one to look if we have the same answer as this. Okay, the tension here is equal to M2G minus M2A, right? So our M2 is what? M2 is 0.015, right? 0.015, then times G is 10, then minus M2 again is 0.015, then times A is what? A is 0.0744. Okay, so let's do it and see if we arrive with 0.148. Okay, so 0.015 times 10. Okay, give us 0.15, then minus, if we do this one. Okay, so minus, okay, 0.015, then times 0.0744. Okay, we have what? We have coming. We have 0.0116. Okay, 1 2 3. Okay, we have 0.0116. Okay, so if we subtract it, let's see what will be our answer. 0.15 minus 0.0116 will give us what? Give us 0.138. Okay, of which is contradicting. Let's do it again. I'm coming. Okay, let's do it again. So our tension is equal to M2G minus what? M2A, right? So let's continue. M is what? M2 is what? 0.015. Then times G is 10. Then minus what? M2 is what? Is still 0.015. Then times A is 0.0744. Okay, so let me just do everything straight with calculator. 0.015 times 10, then minus 0.015 times 0.0744. Okay, when I did it directly, we have what? Tension is equal to what? 0.148 Newton. 0.148 Newton. So that will tell you that the tension acting on M1 is the same as the tension acting on what? On M2. Okay, so you can also use this method to know if your calculation is correct or not. Okay, because you will always arrive at what? The same answer. Okay, 0.148, 0.148. So the tension is 0.148. Don't worry about it. Worry about the force on the pulley. Remember, I told you guys that the force on the pulley is equal to what? Root 2 tension, or we can use 1.4142 then times the tension. So let's use this one straight. Okay, so 1.4142 times our tension. Tension is what? 0.148, right? So times 0.148. So let's do it. Okay, let's do it. I'm coming. So let's do it. Okay, so 1.4142 times 0.148 give us for 0.21 Newton. So this is the total force or the net force on the pulley. Okay, so it's very easy. Okay, this formula to calculate for the acceleration. Okay, the formula to calculate for the acceleration, the tension. This to calculate for the tension, or you can use T is equals to what? M2G minus what? M2A. Or yes, you can use this one or this for tension. Then for the total force acting on the system is equals to root 2T, or you can say 1.4142 times the tension. Okay, so that is just it. Now let's move to the next applications